MCNG132 online. As I was watching the discussions last week, we did some really good topics of like, why aren't companies using this? This is a better source of encryption. And that is the case for a lot of things. Like, why isn't a company implementing two-factor authentication, having a key fob? I wish I had my phone on here. Having a key fob and something else just to log in their local device. Why aren't? This even rolls back to like our second week when we did the USB. Why aren't companies locking their USBs? Simply, I guess the focus would be that there's so much insecurity, or there's so much contained within the world of security that it's hard to look out for everything. And a lot of postures were like, oh, yeah, this is secure. We can leave it alone now. And that was it. They wouldn't pay more attention to it, or when they harden it, they would think that would be the end of it. And as we found out that even through like audits, companies that get this information should act on it and change something internally. That's what you do in audit, is to find discoveries within the system, good or bad, and say, okay, if this is a bad, we need to improve on it. If this is good, we need to keep on doing something similar like this to other areas. So why aren't people all using SHA-256? Don't know. I don't know. You would think that in this world that we'd go to the most, or maybe not the most encrypted, the highest level of encryption, but you think we would use something at least secure. Since today's computers are much faster than they were 5 years ago, which are much faster than they were 5 years ago from that. That's a very good focus there that you found. Let's see, I think Thomas had another. I forget what Thomas had another topic. Yeah, here we go. How long do you think this the technology is introduced? Do you think it will be cracked? It just takes time, really, and that's what we're working against in the security field, is time. As soon as something comes out, perhaps the last thing was cracked, and that's, I think, the development of new encryption methods is because they already seen the shortcomings of the current encryption methods, and that's what's keeping the ball rolling on that. I know we talked about hashes and encryption. I guess different types of hashes, but realize that there's even encryption where you can just simply move binary bits around. My lab computer. What is it? So there's a free tool out in the world. And basically it's just bit swapping. I thought it was a Win7. I forget the real name of it, but it's just really bit swapping. So on top of encryption, just to add another layer of I guess another layer of security, you could just start to swap bits, shift bits. Let's try shift bits. Bit shift. You can start to shift bits left and right to actually move around what's supposed to be seen. Stack Overflow. Check this out. Like I said, there's a program that runs it. I'll have to look up for the exact name. I thought it was something Win in the title. But really, you're just taking that bit. You have 8 bits in a byte. You just take a bit and start shifting it either right or left. If it's on the far right, then it rotates back to the first column. Vice versa, if it's on the far left and you rotate left, it rotates back to the back column. just a way to make data more harder to understand. I do have a file somewhere, and I do have it somewhere. I'll send you guys a look at that. This week we continue on to advanced cryptography, and we look at other methods of how to keep data safe. When we go into the project 4, let's see if it comes up. Okay, that's good. Found that early. I don't know what's going on with D2L. I've loaded all these before, so give me a chance. I'll load them again. From this computer, they might have a different date on them, though. But I think I can manage Libre 5 and kind of manipulate those a little bit. We look at biometrics, cognitive biometrics, how we can encrypt things just a little bit better. Let's see, the weekly reading. Cognitive biometrics really is about addressing how a person understands, how a person thinks, interprets what they're looking at, and maybe that's not in this chapter. I guess not. Okay. So we look at digital certificates, PKI, understanding public key infrastructure, cryptographic transport model, SSL, TLS, SSH, HTTPS. We take a look at how the different protocols interact, not just on ports, but how you start to look at securing these items. Digital certificates, a cool little, besides what you do in project, take a look at the web and look at how you can pay for different digital certificates from different digital certificate authorities. Some certificates can run you like $40, while others cost you a few hundred, and even on top of that, a few thousand. So take a look at those and see that there are different levels of digital certificates to look at. This video is already coming close to past what I want to do. But as you start to work through this week's stuff, I'll post some more additional content. Keep doing those discussions, really, really good on topic. And if you have any questions, let me know. I will get that Lab 4 uploaded now.